So my name is Cheng Yang. You can call me Jack. It's more easy for you to remember. I'm a postdoctoral research associate in University of Florida. I'm working in bioprocessing lab. So today I give you a talk briefly covering all the research project in our lab. You probably wondering what's the picture is here for. Because today we want to talk about a little bit of waste management for helping the environment and reducing the negative impact. And I actually have a lot of experience with K-12 education. And our lab actually provide two things. One thing is we occasionally provide the lab tools. So the student come to our lab, we have real face-to-face observation, and we have a tours. But besides, we also have SSTP program. So the student will be able to independently doing some research projects. So if you're interested, if you have any question about that, you can talk to me later. All right, so let's start. So I know this is very innovative format for us to have a conference or workshop here. So I prepared some refreshments. So hopefully that can help you to stay awake. Now, before I started, I want to talk about a little bit more about myself. So I was born in, here we go, using a pointer. All right, so I was born in China. I earned my bachelor degree in Zhejiang University, which is top 3. And my major is Biosystem and Agriculture Engineering. And then I come to USA. I continue pursuing my PhD degree in Agriculture Biological Engineering Department. And after I earned my PhD degree, I continue staying here as a postdoc. So I'm working in the same lab, bioprocessing lab. So today, here will be some topic I want to talk about. The first one is anaerobic digestion technology. And second one is biosensor integration. And the last one is nutrient recovery. I want to give you a little bit of idea how these topics are connected and why I'm talking about this. So the overall objective for us is trying to using these biotechnologies, recover all the energy or the usable, a very added product from the waste. And we know we have a lot of waste from industrial, we have agricultural residue, municipal waste, and all these waste we can using certain biotechnology for treating them. So here's a schematic. I want to show you the connection between them. As I mentioned, we have a lot of waste to produce in our life. And in this particular case, or in our lab, we're dealing with livestock waste, like chicken waste, dairy waste, or any other related agricultural waste. So we try using the anaerobic digestion technology. This is more sustainable and more environmental friendly technology, and also cost effective. And with this technology, we can convert all the waste into renewable energy. And if you know, one of that is natural renewable biogas. You probably know that, you use it every day. And then how we can improve the efficiency or maximize the output from the anaerobic digestion. We can use a biosensor integration. We can minimize the labor input, and we can maximize the efficiency by optimize all the operation conditions. So with the improved conditions for anaerobic digestion, and now the efficiency will be maximized, and then we still have some downstream we have to take care, and that will be the nutrient recovery, because the phosphorus and the nitrogen in our case will not be recovered by the anaerobic digestion, but we can recover and producing some other very added product. So the whole system will be a closed loop, and we call it circular economy. Now, let's talk about the detail. So there's a lot of waste produced from the dairy or the farms. And here's a photo of the Black Cow Compost Company. And they're using the compost technology for treating the dairy manure or the solids. But disadvantage for using this technology is it's very costly. You have to periodically turn over the pile of the dairy manure. And also it's very dependent on the weather condition. If it's raining, you have to cover all. It's pretty labor cost. And some farms are using the lagoon as technology for temporary storage of all the waste. But both of these technology has disadvantage, like they cannot capture the greenhouse gas emission. So in our lab, we try using the anaerobic digestion. So this photo, I show you, this is a very small scale, a lab scale anaerobic digestion prototype. And on the right side is this black reactor, and that actually contained 5 liters of inoculum, which was able to help us convert all the waste into the energy phase, which is biogas. The biogas including about 60% of methane and 40% of carbon dioxide. So the methane is the one product we want, which can be able to convert it to electricity. So to maximize the biogas production, we have to maintain certain condition. So in this case, pH will be the one, and temperature we have to maintain, and also the loading rate. On the left side, and you can see the counters, this device will be help us to monitor and counting down how much biogas being produced per day. So that can give us an idea how much potential of the waste that we can produce, the potential of the energy we can recover from this anaerobic digestion. But the ultimate goal is not try to discover what will be the energy or how much potential we can recover or how much value-added product we can get out from the waste. The ultimate goal will be scale up and help the community or help the industry to recover more energy, and they can help them to offset the cost. So on the right side, this is scale up reactors. And this particular site, trailer, inside it has the pilot plant scale, which has about a 600 liter working volume reactors. So if any farms they're interested about it, treating the waste, actually they can haul this whole trailer to the site and they can help them to treating the waste. But meanwhile, they can get as an energy from it and also the nutrient. Later, I'm going to talk about the how we can integrate the biosensors. Now, biosensor. In our lab, we're using a microcomputer, and here specifically we're using Arduino. We also can using other type of microcomputer by doing the same thing. As I mentioned earlier, we can maintain all different operation conditions like pH, like temperature or loading rate. So the good thing for this microcomputer is you're able to collect all different data or different sensing function from temperature sensor, from pH sensor, or any other function, you name it. But the most important is it's a closed loop. It can be sending signal out to do the output. For example, the operation condition can be controlled by adjusting the heating plate or the heating unit by receiving the signal from the temperature sensor. You also can adjust the pH by sending out signal and adjust the pump of different dosage of base or acid. Same thing to the moisture. You can offset the humidity condition by input a lot of mist or to make it drier. So this, with the integration of microcomputer, we can help to maintain a very good condition for the anaerobic digestion with minimum labor input. And I mean, who doesn't like the microcomputer can take the data in the middle of the night? You don't have to be there in the lab, especially right now. I mean, it's perfect, right? So that will be ideal condition for our researchers. And the last, for the anaerobic digestion, it only helps us to recover the energy from the waste or convert organics into the energy phase. So now you have the energy, but any reactor is not infinite. So the waste coming in, it must be coming out in another form. So the waste being organic being converted already, but the nutrient, phosphorus, nitrogen will stay in the reactor and eventually go to the downstream. it definitely cannot be discarded into the river system or any water or runoff, because it causes a lot of environmental problem like eutrophication. So in our lab, we use the nutrient recovery technology, and with certain of this schematic show you how this process go. On the way left, we have high turbidity, very dirty wastewater, contain a lot of nutrient. And now with certain technology we've been applied, we'll be able to have a decant on the top is clear, contain less nutrient. But on the top, at the bottom, we have decantate, which contain a lot of phosphorus and the nutrient. You probably want to ask what we can do with that. That's a very good question. So in the bottom, this decanter, we can withdraw that, and with some certain purification purpose. Of course, there's a lot of sand, but after the purification purpose, and here is the final product, or we call a very added product for the farmers. It's called a struvite. So the struvite, the farmers can use that as a very added product from the waste, so they can offset the cost from the market. They don't have to buy the fertilizer. The most important is this type of struvite or fertilizer has very good advantage. It's slow release fertilizer. So you don't have to worry about the runoff or the rain can cause the excessive nutrient you apply to the land. And also you will not damage the soil quality. Now, as I already mentioned too much technologies, I will not dive into the detail. So I'll give you a summarize for that. As I mentioned, we have a lot of waste producing the life. We have industrial waste, we have the agricultural residues, and all this waste has one common feature, is a lot of organics. So with anaerobic digestion, we can convert that organics into the bioenergy, which is methane. And with biosensor can help to optimize the efficiency, and with the efficiency improved, we can also take care of the downstream. But overall, this research project will be serving one purpose for the farms. I mean, this will be in particularly in our case. So I guess that will be all the information I can brief talk about it. And if you have any question, you can put your question in the chat, or contact me later. I think Stephanie also might have my contact information. So that'll be all. Thank you.